Okay. My name is Gordon. My register number is 025CS9082. Now it is here the complete code for the GPU versus CPU subtraction and division operation. First, we are going to import numpy SNP and CUDA.py as a CP for the GPU execution. We are going to import time. From date time, import date time, printf date. We are going to print the date and we are going to print the time and print GPU versus CPU subtraction and division operations. First, we are going to do for the subtraction and division operations. We are setting the initial size of the array like 1 million elements. Size is equal to 10 into 10 to the power of 6. Okay, we are generating random arrays. A CPU and B CPU. A is equal to np dot random size. We are in a random size values between 0 and 1. And a random is for the DCPU, we are adding 1 to avoid the division by 0. Print of array size. So it will show the size of the array. It will show the how much size should be utilized per memory array. Print 250. Okay, now we are going to do the CPU execution, print sequential processes. First, we are going to start time dot time. Subtract CPU. We are going to subtract both the CPUs. Element by subtraction. Division subtract CPU. We are going to divide B CPU divided by the CPU to get the division values of the CPU. And okay, to get the exact CPU time, we are going to use the formula time dot time minus when we start the CPU. So now it will you can print the time. Okay, now GPU execution print GPU will be doing the parallel processing. A GPU is equal to CP dot array A CPU and B GPU is CP Q.py dot array. It will do the parallel processes copy from the CPU to the GPU. Both will do the same. Okay, then cp dot q dot stream dot null synchronize ensure now the GPU is going to be ready. Start to display the functions of the GPU. Start time dot time. Subtraction GPU is A GPU minus B GPU. For the division A GPU divided by B GPU. cp dot q dot stream wait to it will wait for the CPU to finish the process and unlike CPU, GPU has a parallel process. Okay, it will now we are going to print the time of the GPU. Verifying the results. Now we are going to verify the results. Transfer GPU results back to the CPU for the comparisons. Subtract CPU's. Sorry. Okay, now we are going to compare both the GPU and the CPU for the subtraction and division results. Subtract GPU, CPU, CP dot as numpy. Inside the bracket, you're going to use subtract GPU to compare. The division GPU, CPU equal to CP dot as numpy. So as numpy is used to compare CPU and the GPU. Subtraction match np dot l close okay it will match the subtraction and division. Okay, now we are going to print the result. Perform analysis. It will show the CPU time, GPU time, how much speed up is needed. Calculate overhead. Transfer overhead is 0.001 percentage. And print now. Printf note. GPU speed includes parallel computation but excludes initial data transfer. Sample results for okay now we are getting sample results for the first 10 elements. For the first 10 elements, we are going to print the sample elements. These are the expected output. It was showing the exact time, date and time, GPU versus CPU, subtraction, division, and operations. Arrays as we set 10 to the power of 6. It's 1 lakh elements. Memory per size is memory per one array is 7.63 MB. CPU sequential processing. CPU time we took 0.00824 seconds. For GPU, it's parallel processing. GPU time is 0.2256 seconds. Verification. Checking if CPU and the GPU results match. If two results matches, subtraction results matches, yes, true, but revision results also match. Performance summary. CPU time is 0.008234 seconds. And the remaining GPU time is 0.00215 seconds. The remaining of that speed up needed is like 3.8 times faster on the GPU. Okay. Now sample results for the first 10 elements. These are the sample results. Thank you.